Hello, I'm Dr. Ron England, and welcome to COP4708, Applied Database 1, Module 3, Lecture 3, Functional Dependencies. All right, let's talk a little bit about functional dependencies. So, again, this is actually relatively simple stuff so far. Dependency in a functional dependency occurs when you've got one field, okay, that determines the values of all the other fields in a table. So in the example that we've been looking at, if you know the student ID, you know the first name, you know the last name, you know the address, city, state, zip code, all those. You got them. Okay? Because the student ID determines who that student is, and all those other attributes of the student are there. So those fields are functionally dependent upon that specific column, okay, or attribute. Just two ways of saying the same thing. That means the student ID is a determinant. Now, in some cases, we may actually have combinations of attributes that are determinants. And an example here would be if you knew the unit price of something and the quantity of something, you can easily get the extended price, which would normally be the quantity times unit price, except sometimes when you have a specific quantity and a unit price, you get a discount. So it's not necessarily always the case. So how do we use this? Well, this is going to kind of get us into the concept of normalization and how we organize tables. This is important because sometimes you're looking at functional dependencies and you're going, well, is this truly a functional dependency? Reality is, like in this example we have here, it's pretty easy to see that if you know the student ID, all those other values are known. Now, it may be a one-to-one relationship. Student ID would be a one-to-one with social security number. No other student will have that social security number. No other student will have that email. Other students may have that zip code because they may live in the same zip code. But if you know the student ID, you know the zip code. Okay? The fact that other students live in that zip code is really irrelevant. Now, they're not necessarily equations. We have an annotation easily to put them, say. We can say that employee number, okay, and then that good old arrow is a functional determinant of first name, last name, department, email, and phone. Department is not a department is not the determinant, okay? Okay, so employee number is not dependent upon the department. There can be other employees. Now, it seems simple. Try not to confuse you. It really is that simple. So, sometimes you have determinants that are more than one attribute. So, in the case of quantity and unit price, and in a situation where we actually can say, okay, if we have this quantity and this unit price of something, we're going to have an extended price. And if there's a universal discount that goes with it, the extended price might not be the quantity times the unit price, but the examples we're going to use are going to be that. Not, again, don't overthink this. It really is not that difficult. So let's look at, just one here. So if we had, here's an example of a table. This table is a horrid table. Okay, but that's okay. We're going to look at this later. We've got some SKU numbers. SKU numbers would be basically a number of an item, a description, a department. In this case, we put the buyer in there. Really? You get the buyer into the table that has the SKUs. But if you know this specific SKU, now here's the question. Do we actually know that buyer? We do know the description, and it would make perfect sense for the department. But you kind of have to think about that. Now, we're gonna play with this. So let's go here and look at this. We are saying that the functional dependency of the SKU is the description, the department, the buyer. We'll go backwards and look and see that. Okay, so what does that mean that we're saying? They're saying that if you know the SKU, you know the buyer. Okay, that's okay. We're fine. We're calling that a functional dependency. Now, I might use different terminology to do this, but we're gonna stick with that. Now, if you know the description, you also know the SKU, the department, and the buyer. Why is that the case? Because all the descriptions are unique. If a description were to be duplicated and matched to anything different, a different department, a different buyer, a different SKU, you would violate that functional dependency. And that's true in this example right here. There is the possibility that as you add more data, there might be a description that does match. But in this case, it doesn't. But we can see that if the description could have, so if you know that it's a standard scuba tank and it's magenta, the department is water sports, the buyer is Pete Hansen, and the SKU is 100-200. Okay, the table itself shows those to be unique, and therefore it has a functional dependency. All right, so let's go down again. Now, let's do something here. Let's play with this concept of an order item. Okay, we have an order number. We've got 3 orders here. Each of the orders contains an item, or in this case, they all contain 2 items. Each order contains 2 items. They have a quantity of those items and a price for those items. That would be the unit price of the items, and the extended price would be the quantity times the price. We're not going to do anything fancy here. Note that if you know the order number, okay, any individual row, okay, in other words, you've got an order number and you may have multiple items in a single order. And how are we dealing with that? Well, you see that the order number is in the table twice, but for any given SKU, any given item, you don't list it twice. So you don't have order number and then a SKU and then another order number with the same number and then the same SKU. We deal with that in the quantity. Okay? So hopefully you can kind of, what we're really just looking at here is the layout of this table. So in 1000 you got 2 items. 1001 you got 2 items. 1002 you've got 2 items. And if you notice that the item 101, 100 is duplicated between the order number 1001 and 1002. And you got a few things where you know the quantity and the price. So what are the dependencies? Well, if you know the order number and the SKU, you then know for this specific order the quantity, price, and extended price. But if you go backwards, you've also got another functional dependency. You got a dependency that if you know the quantity and the price, you know the extended price. So you've got multiple of those. Again, when you're looking at functional dependencies, if you're looking at a single functional dependency, one item, which is a determinant, then all the items in the rest of that row are going to be determined by that number. In a lot of situations, you're going to have, if you have this and this, or maybe this and this and this, doesn't have to be 2, it can be more than 2, it becomes a determinant for other things. And in this one table, you've got order number and the SKU, which determines everything, and the quantity and the price, which determines the extended price. The important thing is when you're looking at how you design your tables, that you have the ability to recognize these functional dependencies, because what that's going to do on down the line is it's going to determine how you organize and build those tables. So going back to this one, is this a good design? No. Is this a good design? Not really. Okay, but I know it's a bad design because I've identified that I've got multiple functional dependencies in the same table. I would probably want to reorganize this table so that it doesn't have multiple functional dependencies. So what could I do? Well, I could create primary keys where all I actually do is that first table where I have if you have the SKU as a determinant, and that's got the description of the department and the buyer, and an order item can be, well, in this case, we still got order number and SKU go together, make quantity, price, and extended price. This works. It's complex because now I've got SKU, which goes back to being, now, okay, so goes back, do we add a foreign key to the SKU data? Because SKU does determine description, department, and buyer, and the SKU could be a foreign key back to the SKU data, which means that I can always determine the rest of that SKU data from the SKU, but the order item also has the order number in the SKU as a primary key. Can I do this? Sure, I can do this. I can do this. I can say that I can link the table SKU data and order item on the SKU, and SKU is a foreign key that links back, that goes to the order item. So SKU is in both of those, and it can be a foreign key. You know what? There's got to be a better way. So let's look at a totally different example here. Let's look at rental property. Okay, simple. Street, city, state, province, zip code, whatever. By putting in a surrogate key, I've now got one single field column that creates a determinant, and everything else in that row and that table and that row is going to be dependent upon that one key. It's a surrogate key, but it also can be the primary key. That makes perfect sense, because if you look backwards at the rental property without the surrogate key, well, street, city, and state might be combined together to say, okay, that is a determinant. That's a pretty long determinant to work with. So, what is the ideal situation for you to work with? Well, throw in that surrogate key. In design, you should never be afraid to go and throw in that surrogate key. Now, I'm going to work backwards just a little bit and talk a little bit about table design here. This table might make perfect sense to say SKU is, the SKU would be your determinant, it becomes the primary key, and everything else becomes a functional dependent upon that. In the case of the buyer, if all we needed to know is to keep that buyer name handy and the departments like that, that's fine. We may have a situation where we want to actually have the department itself be its own entity. That's okay. That we'll get into the part of the design that we're going to be looking at later. And when I look at this, here's what I see. The department is duplicated, the buyer is duplicated. I only see Pete Hansen as a buyer for the Department of Water Sports. I only see Nancy Myers as a buyer for the Department of Water Sports, but that Nancy Myers actually goes with multiple SKUs. I need more information about the logic that's here to make the decisions. Then when I move down here and I look at this, I've got the order number and the SKU. Well, the order number for the SKU, is there a way that I can actually have multiple SKUs associated with a single order number in a single row? Would that make more logical sense in the way that I design the tables to deal with this? Possibly. Maybe. And then the SKU itself. If the SKU is a functional determinant of the quantity and the price, which we don't know that yet because we haven't looked at that, but if it does have that as being as a possibility, maybe there's a piece of redesign there. Now, hopefully you're not confused, but here is what becomes important. When you're looking at functional dependencies and you're looking at relationships between items that have a level of dependency, you may have multiple functional dependencies in a single table that you put together, and that may mean, you know what, we need to modify this. We need to make changes. What we're going to look at next is what could those changes be. At this point, what's important to know? Functional dependency. That is important. Okay. And the fact that you may actually have functional dependencies that are with multiple columns in a table design. Now let's think about how we're going to deal with them. Thanks, and on out.